The Earth's climate is changing due to a volcanic eruption. Scientists have just discovered something incredible about the eruption of the underwater volcano Hunga Tonga, and it affects the weather worldwide. Be sure to stay tuned to the end to find out all about it. Welcome, friends. Volcanic eruptions, space science. On this channel, I keep you up to date on all these exciting topics, so why not subscribe right now? It costs nothing to subscribe. You will never miss a video again, and you will help me immensely. Thank you, friends. So now let's travel back in time 2.5 years. On January 15th, 2022, a massive volcanic eruption shook the Earth. The Hunga Tonga-Hunga Haʻapai, an underwater volcano in the South Pacific, erupted with an intensity that was unprecedented. The eruption cloud reached a height of up to 58 kilometers, and in addition to a relatively small amount of sulfur dioxide, an enormous amount of water vapor was pumped into the stratosphere. I have to say that the footage from back then simply takes my breath away every time. Look at this raw force of nature raging here. The lightning we can see is also particularly impressive, a perfect example of a volcanic thunderstorm. A phenomenon in which lightning and thunder occur in the ash cloud of a volcanic eruption. It is caused by the electrical charging of volcanic ash particles, which are ionized by friction, in principle similar to a normal thunderstorm, but triggered by the friction of volcanic particles. That's just a brief aside. Today, we are mainly interested in the water vapor that was blown into the atmosphere by this eruption. After all, you might wonder whether this has an impact on the climate. We know that volcanic eruptions in the past have had a significant influence on climatic conditions, sometimes even on the entire globe. The Toba eruption, for example, which took place 74,000 years ago, was one of the largest eruptions in the Earth's history and led to a significant cooling of the global climate, known as the volcanic winter, which lasted an estimated 6 to 10 years and lowered temperatures by up to 3 to 5 degrees. Now I can hear the winter fans among you cheering.
Great, it's getting colder again.
Yes, no, unfortunately not. The peculiarity in this case is that because we are talking about an underwater volcano, it was mainly water vapor that was blown out, and unfortunately this has the opposite effect in the atmosphere. And such a really exceptionally high amount of water vapor has potentially profound effects on the Earth's climate. Now, there is a new study by scientists from the University of New South Wales in Australia, which has examined the long-term effects of the Hunga Tonga eruption in great detail. And believe me, the results are quite something. The researcher involved, Dr. Martin Juncker, says, "Our results show that the volcano can explain last year's large ozone hole and the many wetter than expected summers of 2024. The eruption could have lasting effects on our weather for years to come." The researchers used data from NASA's microwave limb sounder instrument and the whole atmosphere community climate model to simulate the impact of the water vapor anomaly caused by the eruption. The scientists describe it as follows. We ran 2 simulations with the same climate model. In one, we assumed that no volcano would erupt, while in the other, we manually added water vapor to the stratosphere in the amount of 60,000 Olympic swimming pools. Then we compared the 2 simulations, knowing that any differences must be due to the added water vapor. Yes, and 60,000 Olympic swimming pools is not an exaggeration. Take a look at this image taken by an astronaut from the ISS on January 16, 2022. We can see the impressive water and ash cloud of Hunga Tonga's, an amazing photo. It is interesting that the study neglected the relatively low aerosol load from the eruption and instead focused on the much longer lasting effects of the water vapor, simply because there was much more water vapor than aerosols in this eruption. Let's break it down in more detail so that we understand it correctly. Normally, volcanic eruptions cool the Earth's surface by releasing sulfur dioxide, which becomes aerosols in the atmosphere. These aerosols reflect sunlight back into space, thereby cooling the Earth's surface. A well-known example from the recent past is the eruption of Mount Pinatubo in 1991, which lowered global temperatures by about 0.5 to 1 degree. Incidentally, 1991 is also the year I was born, but I have since warmed the global climate through constant CO2 emissions. But well, the Hunga Tonga eruption was different. It released only a small amount of sulfur dioxide, but injected an enormous amount of water vapor into the stratosphere. Water vapor is a potent greenhouse gas that traps heat in the atmosphere and thus potentially contributes to warming the Earth's surface. The new study from Australia uses chemical climatic model simulations to assess the long-term effects of this water vapor anomaly. And what do they find out? The simulations show that the water vapor anomalies caused by the eruption lead to a strong and persistent warming of the land masses of the northern hemisphere in the boreal winter. At the same time, a cooling occurs over Australia in the Australian winter. The temperature changes can last for several years, and a remarkable finding is that the surface response to the water vapor anomalies is more complex than a simple warming due to greenhouse gases. The researchers found that regional circulation patterns and cloud feedbacks play an important role. In certain regions, such as Scandinavia, this leads to cooling despite the general warming trend. The key point of the study, however, is the finding that large water vapor anomalies can increase surface temperatures in large parts of the world by more than 1.5 degrees. At the same time, some regions may experience cooling of up to 1 degree. The North American and Eurasian land masses are particularly affected in winter, while the Arctic experienced an unusual warming throughout the year. So the Hunga Tonga eruption was at least partly to blame for last year's warm summer. And while we don't have to talk about this summer, I can already hear it raining outside again, but Hunga Tonga could also have had a share in this wetness. The water vapor in the atmosphere creates a short but intense effect that can disrupt the climate for a few years. In the southern hemisphere, the cooling over Australia was particularly noticeable, while the Amundsen Sea in Antarctica was warmer than usual. These temperature changes were caused by a combination of direct greenhouse effects of water vapor and complex interactions with regional weather and climate patterns. And it gets even crazier. The Hunga Tonga eruption could influence the climate phenomena El Niño and La Niña. The study sees a connection between the water vapor anomaly and sea surface temperatures in the tropical Pacific. I have already made detailed videos on El Niño and La Niña, but here is a brief summary. El Niño's Southern Oscillation, or ENSO for short, is a climate phenomenon characterized by periodic fluctuations in surface temperatures in the tropical Pacific and has a significant impact on global weather. There are phases of El Niño: warmer sea surface temperatures, and La Niña, cooler sea temperatures, which then cause different weather conditions. We are currently heading towards a La Niña phase, and the water vapor anomaly in the stratosphere caused by the eruption is likely to have an impact on the ENSO. Specifically, researchers believe that the water vapor will lead to a warming of the tropical Pacific and thus to global climate anomalies. So we can see that the eruption of an underwater volcano in the small island state of Tonga has a massive impact on the entire planet, and will continue to do so for years to come. I find this incredibly fascinating and will keep you up to date with all the latest findings. So subscribe to the channel now and activate the bell. Now I have something funny for you. I used an AI tool to create a song about the Hunga Tonga volcano eruption. And what can I say? It's an amazingly catchy tune. Listen to it.
Beneath waves, a fiery show. Hunga Tonga's power starts to grow. Eruption fierce, the world to know. Water vapor changing winds that blow. From deep below, a force untamed.
It's amazing what AI can do these days, isn't it? If you want to listen to the whole song or download it, I'll post the link in the description, and at the end it will come in full length. Yes, let's stay with amazing geological stories. Under Europe, there is a lost continent. No joke. Under your feet are mysterious lost structures of an entire continent. You can find out all about this amazing discovery and see impressive maps of the new continent in the video at the very end. Otherwise, I'd say see you in the next video. Take care, friends.
Beneath waves, a fiery show. Hunga Tonga's power starts to grow. Eruption fierce, the world to know. Water vapor changing winds that blow. From deep below, a force untamed. Nature's fury never to be tamed. Weather shifts, the world inflamed. Hunga Tonga's legacy proclaimed. Mighty and grand, shaping the world with unseen hands. Eruptions echo across the land. Water vapor, a weather command. Hunga Tonga sight to behold, changing the climate so force untamed, nature's fury never to be tamed. Weather shifts, the world inflamed, Hunga Tonga's legacy proclaimed.